So here's A, y equals 2x minus 1. In order to write something in piecewise notation, we need to first, we write out some steps. We need to find the critical values, which are the x-intercepts. If we think about y equals 2x minus 1, that's the inside. And if we wanted to find our critical value, well, we would plug 0 in for y, add 1 on both sides and divide by 2, and we've got x equals 1/2 is our critical value. If we draw a quick sketch of y equals 2x minus 1, we know that minus 1 is the y-intercept, and we have a slope of 1, so we'd go up 1 over 1. And it would look like this, with this point here, 1/2, comma 0, being our critical value. So step 1 is finding the critical values. And we've done step 2. And our little graph here already did step 2. We determine where our function is positive and where it's negative. I'm just going to add red dots to the part that are negative. So to summarize, it is positive when x is bigger than or equal to 1/2, and negative when x is less than 1/2. So that critical value changes it from being positive to negative. Step 3. We just write it in the piecewise notation. We draw these fancy squiggle marks. We write the positive one. So with piecewise notation, you're going to take away the absolute value bar. We're going to say it's going to equal 2x minus 1 when x is bigger than 1/2. Wherever it was positive, it stays the same. So you wouldn't need those absolute value brackets. However, where it's negative, remember what happens to move it up here? You would multiply by a -1. So you just take your original equation, which is 2x minus 1, and put a negative in front of it. You can leave it in brackets. You don't have to distribute it. Just leave it like that. And then say that happens when x is less than 1/2. And that's the answer in piecewise notation. So let's do part B. Can I scroll up? Not quite. So part B, here we have a parabola. Okay. First thing we need to do is we need to find those critical values. So you make y equal to 0, negative x squared minus 3x. Can you see that you could factor out a negative x? splitting it up tells us that there are two critical values, -3 and 0. So what that means on my graph is -3, 0, and 0, 0 are my critical values. If I was graphing my original equation, the inside, -x² plus 3x, it isn't in standard form, so we can't see the vertex right away. But since we already found both of our x-intercepts, which way is this graph going to be going, up or down? It's going to be going down. So we can get a sense that it looks like this. And from that, you can determine step 2, where is it positive and where is it negative. We can say it's positive between -3 and 0. The way that we write that mathematically is we say -3 is less than or equal to x is less than or equal to 0. And it's negative, those red parts, when x is less than -3 or when x is bigger than 0. We use the word or, not the word and. In mathematics, we use the word or when it can be in one place or another place. We use the word and when it has to be in both places at the same time. So you can't be less than -3 and bigger than 0 at the same time. There's no number that's less than -3 and bigger than 0 at the same time. So in mathematics, we use the word or when it can be in either place. We use the word and when it has to be in both places at the same time. So now that we've found out where is it positive, where is it negative, wow, between has two e's in there. There we go. We can write the piecewise notation. So y is equal to fancy squiggle bracket. We rewrite the equation exactly as we have it, -x² minus 3x for where it's positive. And it's positive when -3 is less than or equal to x is less than or equal to 0. Whoops. And if you'd like to distribute that negative through, it might be nice because it becomes just x² plus 3x, but you wouldn't have to. Just make the whole thing negative when x was less than -3 or when x is bigger than 0. And this is piecewise, so 8, 9, and 13.